Welcome to The Explainer. Today we're going to tackle a classic SQL problem, one that pops up in interviews all the time and can really make you scratch your head: finding consecutive numbers. We're going to walk through 3 totally different ways to solve it, and you'll see how each approach gives you a new way to think about your data.
You know, if you've ever been in a tech interview, you've seen questions like this. They're not really about whether you remember some obscure command. Nope, they're logic puzzles designed to see how you actually think with data. And this one, it's a fantastic workout for your analytical muscles.
All right, let's dive in. Before we even think about writing code, we have to get super clear on the actual challenge. What are we really trying to do here? What does spot the streak even mean in SQL terms?
So, on the surface, it sounds simple enough, right? Just find any number that shows up 3 or more times in a row. But the real trick, the fun part, is figuring out how to tell SQL what "in a row" actually means. That's where it gets interesting.
Okay, here's our data. A simple little table called logs. We've got 2 columns, an ID that just counts up, 1, 2, 3, and so on, and a num column with the values we're interested in. That ID column is absolutely key because it gives us a guaranteed order. This is our playground.
Yeah, I mean, you and I can just look at this and see the pattern instantly. Right there at the top, the number 1 appears in rows with IDs 1, 2, and 3. That is the 3-in-a-row streak our query needs to hunt down and find.
And that's the whole point. After all our SQL magic, the query should spit out just one thing: the number 1. Why? Because it's the only number that met our 3-in-a-row rule.
All right, level 1. We're going to kick things off with the classic approach, joining the table to itself. This is a real workhorse in SQL, and it solves the problem in a very direct, almost physical kind of way.
The best way to picture this is to imagine you print out our little table 3 times. You lay them side by side, then you kind of slide the second copy down by 1 row and the third copy down by 2 rows. And you just look for the one spot where the numbers in all 3 sheets line up perfectly.
So here's the game plan. We do this in layers. First, we join the table to itself to find all the pairs of numbers that are back to back. Then, we take that result and join it to the table a 3rd time to see if any of those pairs has another identical neighbor right after it. That's what turns a pair into a triplet.
And boom, check this out. This is what it looks like when it all comes together. We're joining where the first ID is 1 less than the second, and the second is 1 less than the third, and this is the important part, all 3 num values are identical. With all those rules, only 1 single row makes it through the filter, our streak of 1s.
Okay, time to level up. Level 2 uses a much more modern and frankly more elegant tool, window functions. This is a game changer because it lets us look at neighboring rows without having to do those big, expensive joins.
So instead of making copies of the whole table, window functions like lag and lead give each row a kind of superpower. It can peek at the row right before it or the row right after it. It's super efficient. Lag looks backward, lead looks forward. Simple as that.
So look what we've done here. By using lag and lead, we've basically created a new temporary view of our table where every row knows its neighbors. You can see for each row, we now have its own value, the value from the row before, and the value from the row after, all lined up.
And with that set up, the logic just clicks into place. It becomes so simple. All we have to do now is find a row that's in the middle of a sandwich, where its own num is the same as the prev num and the same as the next num. That's it. That's our streak. Okay, now for the pro-level move. This last one is a really powerful, really clever technique that flips the whole problem on its head. And what's great about this one is that it's perfect for finding streaks of any length, not just 3.
So get this method doesn't care about looking at neighbors at all. Instead, the whole goal is to figure out where a streak of numbers starts and stops, and then give each of those streaks its very own unique group ID.
So step 1, we create what's called a change flag. Look at the table. We just put a 1 every time the number is different from the one in the row before it. That 1 marks the start of a new group. If the number's the same, it just gets a 0.
And right here, this is the aha moment. This is so cool. If we do a running sum on that change flag column, look what happens. Every single row inside a consecutive block gets the exact same group ID. See how the first 3 rows, our streak of 1s, all get the group ID of 1? It's just brilliant.
So now that we've done all that clever work to tag each streak, the rest is a piece of cake.
Seriously, we just group everything by that new group ID we made and tell SQL to only show us the groups that have a count of 3 or more rows. And just like that, problem solved.
Okay, so we've just seen 3 completely different ways to solve the exact same problem. That's great, but it brings up a big question. If you're in an interview, which one do you pick? Which one is the right one?
Well, as you can see, there are trade-offs. The self-joined is easy to understand and works on pretty much any database, but man, it can get slow with a lot of data. The lag and lead functions are clean, modern, and really readable, but they're best for a fixed streak length like 3. And that grouping trick, it's by far the most powerful and flexible, but you better be ready to explain the logic, because it's a little more complex.
Look, at the end of the day, an interview and just being a good developer isn't about memorizing the one best solution. It's about having a toolkit. It's about showing you can look at a problem from different angles and know the pros and cons of each, so you can pick the right tool for that specific job.
And honestly, this is just the beginning. These ideas, self-joins, window functions, dynamic grouping, they are fundamental building blocks. You can take these exact techniques and adapt them to find all sorts of incredible patterns in your data, like finding out which users have a 7-day login streak, or where the gaps are in your sales data. The patterns are all there.